So to remind you, for the final exam period, which we have, it's the 12th, right? Yeah. Tuesday the 12th, which is the week after next. The Monday lab group will be starting at 11 o'clock and the Wednesday lab group will be starting at 12. That'll be in room 500. It's the practical that you'll be taking, so we need to do that in the lab. The staggered start times will address the fact that there's actually more people in the class than fit in that room at one time. So Monday at 11, Monday lab group starts at 11 on Tuesday the 12th, and the Wednesday lab group starts at 12 on Tuesday the 12th. Regardless of your start time, you will have an hour and 50 minutes to complete things. That's the full lab, the full exam period. I rarely ever have anybody that needs to stay past the end of the actual period, but if need be, I can stick around with that. I actually have to be around for my NAEG class that night anyway, so I'm not in a rush to get out, and if you need more time, you'll be allowed to have it. All of the work on Blackboard needs to be done before you come in for that. Whatever time I just said applies to you, that's when you'll, I'll cut off the access to Blackboard for you. So if you're in the Monday lab group, you'll be coming in at 11 on that Tuesday, and when your class is in and start taking the test, I'll get on Blackboard and shut things down. And then for the Wednesday lab group, when you come in at 12, I'll go in and shut down access for that. So, it does say for everybody, things are due at 11 on that Tuesday, but for the Wednesday lab group, because of the staggered start time, I won't shut that off for you until after you come in for the test. I think that's everything. So we're continuing on with the reproductive system material. Something I've been meaning to do for a long time. So here finally at the end of the semester, I've actually put some work into doing this. I need to do it for the entire course, but for the reproductive system presentation, some of which I've already used in covering some of the information for the reproductive system, I've actually finally gotten around to updating it with pictures from the book that we're using. So I'm going to use this for the presentation rather than pulling up the pictures separately out of the book like I've done in the past. And for those of you that are in the Wednesday lab group, when we have our next lab, we'll be looking at some of this also to talk about function of the system overall and the male system. But here for lecture, we're concentrating on the female system. And last time I was going through this, so I just want to get back to that same part. This is just the structures of the female reproductive system. Weird. Okay, I apparently forgot to put the little notation in this that would go to this picture, but I showed you this picture before, demonstrating the steps in division, producing an egg cell, the meiotic divisions that take place in the ovary, and then which end finally after exposure to the sperm for the final division there. As I was putting this stuff together and changing the pictures over, there's not a picture in the book that quite shows this, so I pulled this picture down. the book was produced under what's called a Creative Commons license, which is, instead of copyright, the book is available for anybody to use, given attribution. So in the presentations, I want to stick with that ideal. And so this picture is actually from Wiki Commons, which is a collection of a lot of the pictures that are used on Wikipedia. And so there's a link to where the actual page that I got it from is. But this is a drawing of the a kind of picture that's often presented in these courses at this stage. I have a problem with this kind of picture, but there's really not a better way to do this short of generating a high quality animation, which would take a lot of money and time, and I'm certainly not going to be able to do it. So this is showing an outline of the ovary, and in the outer region, so sort of this part where all the drawings are shown, this is the ovarian cortex. The center, where there's nothing drawn in here, would be the ovarian medulla, which really is just where the blood supply comes in. So as far as the function that we're talking about for the ovaries, the medulla isn't crucial. There's nothing really going on there. What I don't like about this picture is that it's showing these steps as if it's all happening in the ovary at one time. Really, this is sort of like looking at the steps as we progress through this, I don't know, kind of like a film strip. It necessarily provides an incorrect view, which I'll try to explain. But this is sort of a summary picture that goes with the pictures I was showing you last time, which were these sets of images from the book. So I guess actually the book doesn't have this picture, possibly because of the issues that I'm about to talk about. But this shows the primordial follicle that then develops into, so here's a primordial follicle, which is in the cortex all the time. Those are the cells that were generated in the embryonic ovary before the woman was born. And then after puberty, these cells start to progress through the events that we see here. And so as the follicle starts to develop, it's the primary follicle. And then when the granulosa cells surrounding it get thicker and then start to separate, so that there's a gap in there. This is the secondary follicle. When I was showing you the picture of the secondary follicle from the book last time, this one up here, I mentioned that this is a somewhat misleading picture because it makes it look like the oocyte's just floating in the middle by itself, but actually it's attached to the side. And so this picture depicts that sort of thing, that the oocyte is within this little mass of granulosa cells off to the side, not floating in the middle. It depends on where you cut through this section. If you happen to cut through right here, you see that it's attached. If you cut through, well, the way this is drawn a little funny, but if you cut through at a different angle, you don't see where it's actually attached. So it seems to be floating in the middle of things. But this is a better representation of how it's attached to the side of the follicle still. That secondary follicle continues to develop and gets larger and larger to the point where it becomes the mature follicle or the tertiary follicle. I prefer mature follicle as a term because this is the follicle as it's gotten to the end of its development. The next thing that happens is that the follicle ruptures and the oocyte's released at ovulation. The remainder of the follicle, after it's ruptured, everything else that's still part of the ovary persists as this structure called the corpus luteum. Ovulation takes place at the halfway point of the ovarian cycle, so at 14 days. And so the last 10 to 14 days of the cycle, the corpus luteum is present. It will, towards the end of that time, at around 10 days, start to degenerate down into a smaller structure, which here is labeled as the degenerating corpus luteum. Some sources will refer to that as the corpus albicans. As I was talking about the corpus luteum last time, the word luteum refers to the fact that it has a yellowish appearance. The tissue is kind of yellow. Corpus albicans means that it has a white appearance. So when it degenerates away and it's no longer functional, it's white in appearance, and it kind of looks like scar tissue, which is not an unfair description of what it is. But that's what happens at the end of the ovarian cycle. And again, it's really the second half of the ovarian cycle. There seems to be a lot more happening before we get to the ovulation, but that's just because the follicular development is sort of a big deal in understanding what's happening there. Now, the big problem I have with a picture like this is that it's showing that everything seems to be happening along the cortex like it's moving through there. That's actually not true. If this is where the primordial follicle is located, where we go, up in this corner, it's going to stay there and develop, and the follicle will get bigger and bigger until it matures, and it'll rupture here, and the corpus luteum will stay in that area. These structures don't actually migrate through the cortex. They've just done that here for the sake of putting them all in the picture together. A better representation of this would be to have an animation of some sort where you could see the follicle progress through its different levels of development in the same place until it ruptures at ovulation, and then the corpus luteum is what remains there. That all happens in the same spot. The cortex all over is just filled with a bunch of primordial follicles. And so each cycle, a primordial follicle somewhere in there, kind of at random, enters into this developmental progress, and that area goes through. And then the corpus luteum, corpus albicans that's left over at the end is just the remnants of what happened there. And in another place, the same series of events happens again in another cycle. So this is just showing all of the things that are happening over the course of 28 days in one picture, kind of like this picture from the book is showing the three things at the top and down here, which is the follicular development, and then here's ovulation, and then they just have this one picture of the corpus luteum, which really is the second half of the whole process, but there's not a whole lot to show for that. So, like I said, the book didn't have this sort of presentation. I just put it in there, coming from the Wiki Commons image resource, just so you can see that sort of thing. Someday I hope to find a good animation to depict this in a more realistic presentation, so that it's all happening in one place within the cortex, which is what it would really be doing. So I showed you this last time in more detail. I didn't show you any of this. This is the hormone stuff. Okay. So these three figures are, the light's a little bit strong here, are showing the interactions between a few different glands via hormones that regulate what's going on here. Now, reproductive function is regulated through the hypothalamus. The hypothalamus releases a hormone called GnRH. That abbreviation is sufficient to refer to it. It stands for gonadotropin releasing hormone. A gonadotropin is a hormone that has an effect on the gonads. So gonadotropin releasing hormone coming from the hypothalamus tells the anterior pituitary to release the gonadotropins. The gonadotropins are LH and FSH. Again, we can just refer to them by their abbreviations, but what these stand for, FSH means follicle stimulating hormone, and LH means luteinizing hormone. What they do is they stimulate the follicles to develop, and actually follicle stimulating hormone is named specifically because of that, and is primarily responsible for telling the follicles to develop. There's a little bit of luteinizing hormone, but it's not as big a player at this point. When the follicles are developing, they're going to start to produce and release hormones themselves, which will then get into the bloodstream and target the uterus. And we're going to talk about the uterus a little bit later on, but this ties everything together. So the hypothalamus is in charge of everything, releases this signal that sets off the 28-day cycle. The anterior pituitary releases these two hormones, which stimulate the ovaries to do what they're supposed to do. And coming from the ovaries, estradiol, which is one of the estrogen hormones, will have an influence on the uterus. There's actually three things here, three different graphs or figures, because they're showing three different parts of the process. A little cutoff on the screen here. But we start with the follicular phase, which means the first half of the process. So this is when the follicles are developing, getting up to the mature follicle stage. It's driven by mostly FSH, but LH is present to some degree too, under the direction of GnRH from the hypothalamus. And the estradiol released from the follicles will influence changes in the endometrium of the uterus. Estradiol also acts as a negative feedback signal. Basically, the hypothalamus and the anterior pituitary are saying, okay, follicles, start growing, start making estrogens. And when those estrogens, namely estradiol, are being made, as the concentration of estradiol in the blood increases, it starts to turn off the expression of the hormones from the hypothalamus and anterior pituitary. The ovaries are getting the signal, they're making the estradiol, so the estradiol acts as a signal back to these two levels to slow down the release. Now, actually, on the anterior pituitary, what it's doing during the follicular stage is not telling it to stop making those hormones, but actually just to stop releasing the hormones. The hormones are still being made, they just stay in the cells while estradiol is at the levels causing this negative feedback inhibition. Then we get to ovulation. At ovulation, the estradiol levels have gotten very high. The follicles are just pumping out estradiol the whole time. And so for most of the follicular phase, the levels are low enough, or at the level, the levels are, the hormone is at the levels that inhibit hormone secretion. But then when the concentration of estradiol gets very high in the blood, which is going to be around day 12 or so, then it switches from being inhibitory to being an activating signal, and the hypothalamus releases a little burst of GnRH again, which then tells the anterior pituitary to release the hormones that it's been saving up. So here, the anterior pituitary is still making FSH and LH, it's just not going to release it as much because of the inhibition from estradiol. But then at this point at ovulation, suddenly everything that it's been making and saving up gets released. The thickness of these, I think the video just cut out if you heard that little beep. I got to figure out why that happens. Anyways, the thickness of these arrows is actually somewhat significant. The LH arrow is a little bit thicker than the FSH arrow because the concentration of LH coming out of the anterior pituitary at this time is huge. And it's really what causes ovulation to happen. LH stimulates the follicles to rupture, and that's when ovulation takes place. Now, the follicles are still making estradiol and releasing that, and it has its effect on the endometrium and the feedbacks that I just mentioned here. It stimulates the ovulation. Then after ovulation, the ovaries are in what we call the luteal phase, because this is when the corpus luteum is going to be in charge of things. Now, LH stands for luteinizing hormone because after causing ovulation, it's mainly there to cause the remnant of the follicle after ovulation to become the luteinizing, to become the corpus luteum. The corpus luteum then starts secreting progesterone. Now, actually, it still secretes a little bit of estradiol, but progesterone's its major secretion here. Progesterone then has an effect on the endometrium of the uterus, just like estradiol did, but it has a different effect on it. And progesterone acts as a feedback signal, again, inhibiting the hypothalamus and the anterior pituitary. And this is going to lower the levels of production and secretion here, bringing the cycle to an end. So after 10 or 12 days of progesterone signals going back here, everything will shut down and the cycle will end. And then it'll start back up again shortly after that, and we'll just keep going through all these things. So those are the hormones that are involved in the glands that secrete them. After looking at a couple more things, we're going to come back to this idea, but look at it in sort of an overall picture of how all of these things are playing together. This is a picture of really a lot of the structures, and I'm putting this here now because I want to talk about the uterus. Now, in this picture off to the side, this is a micrograph of the ovary, which we've already talked about, but it's in this figure, and it's kind of hard to cut it out of this figure. What I really want to talk about is the wall of the uterus. The inset that we see here is showing you what we have of the uterus. There are 3 layers to the uterine wall. And in a lot of these organ systems we're talking about here at the end of A&P2, we think about the layers of the organ wall. So the blood vessels, the digestive system, the bladder, the uterus, we keep talking about these things. Generally speaking, they're all kind of the same structure. They're not always referred to in the same way, but the innermost layer is a mucosa, which has an epithelium associated with it, and then connective tissue. There's usually quite a bit of connective tissue. In the digestive systems, we separate that into the mucosa and the submucosa. In the urinary bladder, it was just one layer. And here it's just one layer by name, but it actually has 2 parts to it. And it's called the endometrium. Metrium is referring to the uterus, so endometrium is the inside of the uterus. And then past that, we have the myometrium, which is the muscular wall. And that's actually quite thick. For the inset here, what we're looking at, let me zoom in a little bit. We just see muscle tissue here at the edge, but the muscle is actually a lot thicker than the endometrium. We just don't have a whole lot of it in the inset. Then the outer covering, which is not in the inset, what's surrounding the uterus is the perimetrium. Again, metrium referring to the uterus. So perimetria means around the uterus. And that's essentially a serous membrane kind of arrangement. Okay. It's not a serous membrane like the pericardium, the pleura, or the peritoneum in the digestive system, but it is covering that. It blends into some more tissue, which is labeled here as the broad ligament. Well, they don't have it labeled down here, but this sort of big wing of tissue here is sort of where that serous membrane helps to anchor things in place. So those ligaments are really the attachments that are sort of continuations of the perimetrium as it extends away. So those are the layers there. The myometrium muscle is very important for childbirth because when it contracts, that's what pushes the newborn into the birth canal. What we're interested in here, however, is the endometrium. Now, there's actually two regions of the endometrium, and that's not highlighted in this picture, and it's actually kind of hard to see exactly where it is. But the endometrium has two layers. There's one layer that's called the functionalis, or the functional layer, which is the deepest part, which is right next to the myometrium. And it's, generally speaking, not a very thick layer. You could think of it as the submucosa for this organ, although it's not what it's called, but it's a layer of connective tissue deep below the mucosa, but not in the muscle layer. And then the rest of it is what's called the, I got that backwards. I do this all the time. I'm really sorry. I call that the functional layer. It's the basal layer, which should be obvious because it's the base of this endometrium. The other part is called the functional layer. Sorry, I got that backwards. So the basal layer is just the rather thin part where it's attached to the muscle. And then most of the rest of it's called the functional layer, or the functionalis. The functionalis, or functional layer, is part of the endometrium that changes its thickness over the course of the uterine cycle. Now, I was talking about the ovarian cycle a little while ago. That's a 28-day cycle, which has ovulation happening right in the middle at day 14. The uterine cycle is also going to follow 28 days because it's tied to the ovarian cycle. And actually, it's tied to it because of what I was just showing you here, that the estradiol or progesterone coming from the ovaries is influencing activity in the uterus, specifically the endometrium. So the functional layer at the beginning of the uterine cycle is going to slough off. It's going to become detached and leave the uterus. And that's the section called menses, the menstrual flow. It's a highly vascularized tissue, so the menstrual flow has blood associated with it because it's coming out of that tissue. Then after it's sloughed off, which should be after about 5 days, the functional layer is very thin, and so it starts to grow. And the rest of the first half of the uterine cycle is called the proliferative phase because the functional layer is proliferating. It's growing thicker. And that's what estradiol does. It causes proliferation of the functional layer of the endometrium. At the point of ovulation, the functional layer actually isn't completely at its full thickness. It's still going to be growing a little bit. But when progesterone starts to be released from the corpus luteum after ovulation, the functional layer starts to secrete material from what are called the uterine glands. And you can see this crevice right here and the hint of a lumen there. And if you look closely at this kind of tissue, there are little glandular crevices going back in there. And so the endometrium is secreting its mucus, so to speak, but it's a supportive fluid that'll help if there's a zygote that's going to implant into the uterine wall. So progesterone causes secretion of stuff from these glands. And so the second half of the uterine cycle is referred to as the secretory phase. Actually, let me do something real quick. Oh, good. It might not have. I was afraid I lost the video there, but it looks like the video is still working. So let me just write some of that down for you real quick. Okay. So we have the ovarian cycle, which has the follicular phase, and then ovulation at day 14, followed by the luteal phase. So the follicular phase is everything up to day 14. The luteal phase is everything after day 14. For the uterine cycle, it starts with menses, which is usually about the first 5 days, followed by the proliferative phase, which ends on day 14 with ovulation. And then we go into the secretory phase. During the follicular phase in the uterus, first off, the functional layer from the previous cycle is released, and then a new functional layer grows up, and at day 14 of ovulation, the signal switches from the ovary. It's been getting estradiol causing proliferation. After day 14, the ovaries start to release progesterone. Now, like I pointed out in the figure I showed you a little bit ago, it says estradiol for the follicular phase and ovulation, then says progesterone under the luteal phase. In the luteal phase, it's actually still releasing some estradiol, but not nearly as much as the progesterone that's being released. And so progesterone stimulates the secretory phase in the uterus. Okay. So just a quick summary of those points that I've made there. Okay. So I want to talk a little about the hormone levels and what's what I'm looking for, regulating all of this. Before I get to talking about the stuff on the far side of the screen from me, which is the cycles and all that, I want to show you this picture. Again, this is not from the book, but I think it's an important point to make. Please do not be scared by what you see. The problem with talking about anything chemical in nature is I need to be able to show you something on the screen when I'm talking about it. And so I'm necessarily going to show you chemical formulas. I do not want you to study the chemical formulas in a lot of detail. But the point I want to make here is about the similarity in structure in a lot of these hormones. Okay. Now, again, I'm trying to find images that are not copyrighted to use for this sort of thing. And so I found this, and it's a little bit more than I would have wanted to put here, but it does make the points I want to. So the hormones we're talking about belong to the group of hormones that we call steroid hormones. And steroid hormones, by definition, are derived from cholesterol. So this is the structure of cholesterol up here at the top. And what we can kind of pick out about cholesterol all the time, unique about it is its ring structure. So it has these 3 6-sided rings and a 5-sided ring arrayed like this. And then for cholesterol, there's a little chain sticking off of it up here. Cholesterol is modified by a series of enzymes to give us the hormones that we're interested in. Now, in this picture, there are a lot more hormones than we really need to worry about. But there's an enzyme, which they don't provide a name for here, that removes or cleaves the side chain off of cholesterol, and we get this thing here. And then another enzyme ends up giving us progesterone. So when I talked about progesterone, the hormone that's being released from the follicles causing the secretory phase in the uterine cycle, that's it right there. It's chemically not very distinct from, or I shouldn't say that, chemically not very removed from cholesterol. I'm assuming that cholesterol side chain cleavage enzyme is one chemical step, and then the other one there is a second chemical step, and we get to the progesterone. Okay. Whether it's 2 enzyme steps or not, it doesn't really matter, but it's an early stage of modifying cholesterol into steroid hormones. From this, we can make a few other steroid hormones over here that don't have to do with what we're talking about. Let's see. Where am I going with this? Yeah. So progesterone is modified by this enzyme to get down here, which is modified by this enzyme to get down here, which is modified by this enzyme to get down here. And now we're at testosterone. Okay. So I don't really care too much about these intermediate steps. I'm showing you that from progesterone to testosterone, there's a few enzyme steps to get down there. Okay. Testosterone is, which you're probably familiar with, the male sex hormone. It's just related to progesterone. Progesterone is made in men, but it's only really a precursor to other hormones. And we don't care too much about the other hormones. Some of them you might recognize their names, but they don't have to do with reproduction. We're just interested when we get down here. Okay. So in men, progesterone is just a precursor that goes through a few steps to get to testosterone. Also in men, testosterone can be changed slightly into this other molecule here, which is called dihydrotestosterone, or DHT. And that's an equally common sex hormone in men, androgen in men. And if you pay attention to any of the commercials about low testosterone levels and that sort of thing, they mention DHT. DHT? Yeah. There, because it's as important as testosterone itself as a hormone in men. But what I want to point out is from testosterone, one enzyme changes this molecule into estradiol, which is the estrogen that we've been talking about here. Okay. So let me zoom in on this, because this is actually something I want to make a point of. The enzyme that makes this change is called aromatase. Aromatase is an enzyme that creates an aromatic ring in an organic molecule. An aromatic ring is denoted in these kind of pictures with one of these 6-sided rings that has 3 double bonds drawn in. So over here in estradiol, this ring with the 3 double bonds, that's an aromatic ring. Okay. Now, you hear the word aromatic, you probably think of it as, associated with odor or something like that. Chemically speaking, that's not necessarily true. Very strong smelling chemicals tend to have aromatic rings in them, but I don't believe estradiol is one, or the estrogens in general are one, because it's a minor, not a minor component, but it's not an overwhelming component of the whole molecule. An aromatic ring that is really stinky is this stuff called toluene, which is an organic solvent, and it's just you can smell it from miles away practically. It's really, really aromatic. But so aroma in this word doesn't actually have anything to do with smell. It's just a chemical name for it. And so all that's happening to convert testosterone to estradiol is this ring here, which only has one double bond in it as testosterone, is changed so that it has 3 double bonds. And by doing that, the carbon at this corner has 4 bonds, 1 in the ring going up, 1 in the ring going down, and 2 going to this oxygen. It needs to be changed so that it has 3 bonds within the ring and then only 1 available to connect to oxygen. So that oxygen has to have a hydrogen on it. And then over here, this carbon is sort of rearranged a bit because instead of the 4 single bonds attached to it, it's going to be involved in a double bond. So this line comes off. That line is suggesting that there's another carbon sticking off of the ring there. And so that carbon that's at the end of the line here gets removed. That's the only difference, chemically speaking, between these. Okay? Just changing that ring to aromatic. And in doing that, we can see some changes. There's that line sticking off that would have a carbon at the end is gone. And then the double bonded oxygen is now single bonded and it has a hydrogen attached to it. It's been a little while since I actually sat down and did this, but I think that the difference between these 2 molecules is only 5 atoms. We take away a carbon and 3 hydrogens, and then we add back another hydrogen, and I can't remember what happens with other hydrogens in that ring. But there's just a handful of atoms that are different between these 2 molecules. And 1 enzyme is all that's required to do that. Progesterone, like I was saying earlier, is a precursor to a bunch of different hormones. And in men, it goes through a few enzymatic steps to give us testosterone. In women, it's also going to do that. In women, progesterone is going to go through a few steps to make testosterone. And then testosterone is converted to estradiol. In the ovarian cortex, the cells that are making the hormone within the follicles are actually making testosterone. But then other cells in the ovarian cortex have the aromatase enzyme that convert the testosterone to estradiol before it leaves the ovary. So functionally speaking, the ovaries are making estradiol. That's all we care about. The point I'm making here is that these 2 molecules are very, very similar, and they're actually very closely linked in the hormonal functions that we're talking about here. But they have vastly different effects. Okay, testosterone is present during development to make male reproductive organs, to masculinize the embryo. And without testosterone being active like that, the embryo is going to be feminized, which is actually going to be partly responsible, or not responsible, but partly due to estradiol. Okay. These 2 molecules are very, very similar, but there's just this little change at the chemical level that has vastly different effects on the embryo, making the embryo either masculine or feminine. Why do these very, 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 very similar molecules have such very, 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 very different effects? How can 2 hormones have 2 different sets of effects? See, I'm doing this thing at the end of the semester that I'm expecting you to think back to stuff you studied earlier in the semester. What is it that hormones need to have an effect? Receptors, right. So while testosterone and estradiol are very, 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 very similar molecules,
The differences come from the fact that testosterone binds to the testosterone receptor and estradiol binds to the estrogen receptor. And as a complex, the hormone receptor complex is significantly different. So testosterone causes its changes in the nucleus, and estradiol causes its changes in the nucleus of target cells. Okay. So it's about the receptors. Okay, sort of coming back around to the endocrine stuff we talked about, regulation and targeting. These two very similar molecules end up having different effects because of their receptors. That makes them completely different. Okay. As I've been talking about this, and in the book, they talk about estradiol as the molecule, the hormone. You'll often hear reference to estrogen. Estrogen is not a hormone. It's a family of hormones. Estradiol, which I've been pointing at here, and then right above that in this picture is estrone. And I don't think the other one's in here, but there is another estrogen hormone. I think it's called estriol or something like that. But those three hormones belong to the group called estrogens. And most sources, or most people, will kind of refer to estrogen as the hormone, but it's really a type of hormone. Estradiol is the primary one. Testosterone belongs to a group called androgens. So androgens and estrogens are sort of the two equivalent groups. And so testosterone and dihydrotestosterone are both androgens. So they fit into that group together, as well as this other one that I'm not going to even try to pronounce its name here. Those are androgens, these are estrogens. They're very closely related molecules, but they have vastly different effects because of their receptors. So again, the point of this picture wasn't to scare you with all sorts of different chemical structures. I just wanted you to see some of the relationships. Everything's derived from cholesterol. Progesterone is an early variant of cholesterol, which is the precursor to a number of other molecules. We're interested in testosterone and estradiol as the two main hormones. So what we were just talking about, estradiol and progesterone are the two hormones that are used to regulate female reproductive function. And they, coming from the ovaries, they influence what's happening in the uterus, tying those two cycles together. So this picture kind of gets at tying those two together. For the sake of the book, this is kind of where they put together some of what's happening in making the follicles develop. So multiple primary follicles will be stimulated by FSH to start developing, and they become primary follicles and they grow into secondary follicles. Only one of them makes it to the point of being the tertiary or mature follicle, which is then going to rupture at ovulation. So all this stuff up here, they put it separately because it wouldn't really fit into the space allowed in the figure down here. But what they're showing is really multiple primordial follicles are stimulated by FSH, and they will progress through some of the development, but only one of them will get to the stage of being a mature follicle, which is going to rupture at ovulation. Okay. And then after ovulation, we have the corpus luteum, which will persist for most of the time here. In this picture, they kind of have smaller and smaller versions of it. It doesn't immediately start getting smaller and smaller. It'll progress, or it'll persist for a while, and then sort of in the last week or so really kind of degenerate away the most. So, but the second half of the ovarian cycle is the luteal phase there. Okay. Then down below, we have a representation of the uterine phase, uterine cycle. So the first part of it is menses, where menstruation takes place. And then after the endometrium detaches and thins out, it starts to grow back, which is the proliferative phase. And then at day 14, which corresponds to ovulation in the ovary, we switch to, like I do this. The uterus switches from proliferative to secretory phase, again, because of the switch in the hormones. Down at the bottom here are a couple of graphs showing what's going on with these hormones, okay? So the top graph are pituitary hormones, FSH and LH, and then the bottom one are ovarian hormones, estrogen and progesterone. What's not represented here is the GnRH, what's being released from the hypothalamus. But that's what gets all of this started. So as GnRH levels increase coming from the hypothalamus, the pituitary is going to start releasing FSH and LH. And the levels of those are going to start to go up in the blood. Okay. And FSH is a little bit higher than LH. It's primarily responsible for stimulating follicle development, which is going to cause an increase in estrogen levels. Okay. Now, as these estrogen levels are increasing, sort of this part of the curve in here, they act as an inhibitory signal, keeping the FSH and LH levels low. Okay. They're doing it by keeping it from being secreted. It's still being made in the pituitary. It's just not getting into the blood, so the levels stay low. When the follicles have reached their rather mature state, the mature follicles putting out a lot of estradiol, or the estrogen type hormones, and when it reaches its peak, it suddenly becomes an activator. Instead of inhibiting the release of LH and FSH, it stimulates that release. So it's been made all along and stored up in the pituitary, and with that peak in estrogen levels, that's what causes the release. Now, while FSH levels were a little bit higher than LH levels here during the follicular phase, not nearly as much FSH is released as LH. Okay, really significant difference there. It's really the LH that causes ovulation. Okay, and because ovulation's been caused, it's going to become the corpus luteum. The remnants of the follicle will become the corpus luteum, so it's called luteinizing hormone. Okay, we could, I suppose, call it ovulating hormone because it causes ovulation, but the name's luteinizing hormone because what happens after ovulation is formation of the corpus luteum. Okay, but the levels end up falling off quite a bit, and then here we see that they start to rise again, which is going to be the start of the next cycle there. Okay. After ovulation, the follicle stops making estrogens, estradiol. So its levels start to drop off. But when the corpus luteum starts to become active, it's going to be making hormones also. It starts to make progesterone and some more estradiol. Okay, but the estradiol levels are not as high as they were in the follicular phase. These two together are telling the uterus what to do. Okay, so at this point, after ovulation, it's telling the uterus to enter into its secretory phase. Without the progesterone, estrogen just tells the endometrium to proliferate. When FSH and LH levels have dropped off finally, progesterone and estradiol levels are going to drop off also. When these levels get very low here out at day 28, that's actually the signal to the uterus to go into menses. So it's the drop off of these hormones that causes the start of the next uterine cycle, which is then going to be regulated and followed along by these hormones in the next go round. But it's the end of one cycle that actually starts the beginning of the uterine cycle there. Because of that, we can see how birth control pills work. Okay, if you ever notice birth control pills, they're a combination usually of progesterone and estradiol specifically, not just estrogen. Some I don't want to say recent, but some of the more modern versions of the prescription will actually have low estradiol levels, which is fine because the estradiol is not the big player. It's the progesterone that's really more important. When somebody's taking the birth control pills, the levels of those two hormones are going to be about what we see here in the midst of the luteal phase or post-ovulatory. When the body has these levels of these hormones present, the body thinks that it's in post-ovulatory phase. So it's not going to produce new follicles and there won't be any ovulation. Okay. Then in the typical progression of taking birth control pills, there's 1 week where the pills actually don't have any hormones in them. So the levels will fall off, which will cause menstruation. And then after not taking anything for a week, the pills go back to having post-ovulatory levels of hormones. So it allows for the endometrium to be sloughed off during menstruation, but then it gets back to convincing the body that ovulation's already occurred. So no new eggs or no new follicles are developing and ovulation doesn't take place. So it acts as a birth control method because it fakes the body into thinking that it's post-ovulatory. There's nothing that necessarily says that it has to follow a 28-day cycle. That's just how it generally is done. There are versions of birth control using progesterone and estradiol that last longer. There's a pill form, I think it's called Seasonique, that only goes to low levels causing menstruation 4 times a year. Okay, so every 3 months. Seems like a good idea, but if you listen to the fine print in the commercials, it says that it does not guarantee that a regular bleeding won't occur, spotting and that sort of thing. So it seems like a good idea, but it doesn't always apparently work out the way that a woman's hoping to limit the amount of menstruation. But there's also patches and implanted hormone systems, which will release hormones for longer amounts of time. I have no idea if there's any need for the levels to get low every so often to allow the endometrium to slough off or not, but that tends to happen on a regular basis in whatever it is. But I believe there's an IUD, intrauterine device, that also has hormones in it, which is usually present for a very long time, like a year or multiple years. And so it probably doesn't have any fluctuation in the hormone levels, but I don't know very much about that particular one. I'm more familiar with the pill form because it really fits in with what we're talking about here. But taking the pill helps to keep the body under the impression that it's post-ovulatory, and therefore egg cells will not actually be produced. And that's the source of the birth control there. So now, come on, where is that? Oh, stupid thing. Sorry, sometimes this freezes up. I was talking about this earlier. I'm not going to really go through it again, but I've pointed out a few times. What we're just looking at there is really a graphical representation over the course of the 28-day cycles, representing what's happening here. I also, however, want to go here. This is a picture from the first part of the chapter, which is about male anatomy and function, because this is showing the relationship between all of these hormones and glands and regulating what's going on in the male system. I don't quite know why in the female side of the chapter they don't have an anatomical picture kind of like this, but this does show these things. So the hypothalamus releases GnRH into the hypophyseal portal system, which then goes down to the anterior pituitary, causing FSH and LH release. All of that is essentially the same in the male or female system. What's different in the male system is that males don't have ovaries. So FSH is not going to have the same effect. But it's still the same hormone. And what it does is it causes the cells making up the wall of the seminiferous tubules, which some of you will hear what seminiferous tubules are next week in lab, causes those to stimulate the production of sperm. The cells that are sensitive to FSH are called Sertoli cells, or I think the book also uses interstitial cell, sustentacular cells. Other sources will call them nurse cells. There's a few different terms for them. But they're sensitive to FSH, which helps stimulate sperm production. LH is going to target a different cell in the testes called the Leydig cell or the interstitial cell. Leydig cells are found in the connective tissue in between these tubules. And when they're stimulated by LH, they produce testosterone. Okay. Testosterone will help to feed back and inhibit stuff at higher levels, just like we saw with estradiol in the female system. In the male system, they're pointing out also this hormone called inhibin. Why they don't mention that in the female system, I don't know, but there's inhibin being released by the ovaries also. And it does just what its name suggests, which is to inhibit FSH and LH release, which is really just redundant with the estradiol, but that's what it does. What's not highlighted here, because I think this is kind of already getting a little bit complicated, the testosterone that's released, its main focus is not actually just to feed back and tell everything else to stop doing what it's doing. The testosterone actually is mainly going to target the Sertoli cells also. And testosterone and FSH together are necessary for sperm production. So those will both happen. But using the exact same hormones, GnRH, FSH, LH, in the male system, that regulates sperm production. Now, as we're looking at the female system, it's obviously tied to the 28-day cycle. I'm not familiar how much of a cyclical nature there is to this in the male system, but it is entirely possible. It probably isn't terribly cyclical because there's nothing in this system like estradiol that when it hits a peak concentration becomes activating and releases a burst of LH. That kind of thing doesn't happen here. So I don't think that there's really a cyclical nature to the male reproductive function, although there might be a minor cycle there. I've heard reference to, although I've never looked into it, that men do have reproductive cycles, which suggests that there might be higher levels of sperm production or lower levels of sperm production. But I've never really looked into that very closely, although it would kind of make sense because it's using the same endocrine mechanisms that drive the 28-day cycle in the female system. But this is just to kind of come back and tie some of the function of the male system in with what we just covered in the female system to see that they are very closely related in the mechanisms, and it's just a matter of the difference of what the two systems actually do. But it's about making the gametes that are going to be available to combine and make a new human being in the future. So, anyways, any questions about the reproductive system, reproductive functions? Okay. Some of this might be a repeat. You might have gotten this story, from your mother at some point, explaining what happens, whatever. But this is getting into the more anatomy and physiology side of things, with lovely pictures. So like I said last time, I expected that I would finish out the reproductive system today, and I in fact have. So we do not need to have class next Tuesday, okay? If anybody asks, you're coming to class because you're supposed to, but we'll just consider it an optional class period. And I'm not coming, so if you come, feel free to sit out in the hallway, but you're not gonna get anything out of it. But that wraps things up. I know some weird quirk in the schedule this year. I finished up early. I'm usually kind of going really fast to get everything in by last day, but it didn't happen that way. So remember, the 12th is the final exam period. Well, you'll be taking the second practical. People in the Monday lab group show up at 11 on Tuesday the 12th. People in the Wednesday lab group show up at 12 on Tuesday the 12th. And you'll have an hour and 50 minutes to complete it if you need.
So in short, for the Monday lab group, this is the last class.
Well, Monday we did reproductive, that's last lab. So there's no.
This is our last class for the Monday lab group.
Yeah, I won't see any of you until the final period.